Hello and welcome to another one of D's ADD videos. Today we're going to look at some examples of exponents. Basically what we got going on here is we got to try to find the same base. So can I write 4 as some number raised to a power and 8 as that same number raised to a different power? In this case the answer is yes. 2 to the second power is 4 and 2 to the third power is 8. And if I bring their exponents along for the ride, we get this next step. Then if you have one power raised to another power, what you do is you multiply the exponents. So you got 2 to the 2 times 2x plus 1 equals 2 to the 3 times 3x. And you can set the exponents equal each other and get rid of the bases. What's actually happening here is you're taking an ln on both sides and it's coming down, and this is coming down too, and then you divide both sides by ln of 2 and they cancel and leave you just the exponents equal to each other. But it's a lot easier just to see the final result, and you're going to get the exponents equal to each other, giving you this. Then you just solve for x. So I think I ran out of space a little bit, wrote too big. So if I have 4x, now what I'm doing is I'm taking this 2 and distributing it to both of these, and I'm going to multiply these two 3's together. So you get a 4x plus 2 equals 6. Oh, 3 times 3 is not 6. That's what happens when you're tired, okay? That's why good night's rest is very important. So you subtract 4 on both sides, and you're going to get 2 equals 5x, and 2/5 will equal x. Alright? So again, what did we do? We tried to find that same base. In this case it was 2. Then we multiply the exponents, distribute through, and set the exponents equal to each other. Solve for x. Okay, let's try it again. This time you could do either 2 or you could do 4. Would probably be easier. You want to go with the largest possible common base. 4 squared is 16 raised to the 3x plus 2 equals 4 cubed. And once you get the hang of this, you don't need this step. You can just go immediately to this step. But it doesn't hurt, you know. It shows the grader you know what you're doing. Then you get 4 to the 6x plus 4. And then set the exponents equal to each other. Bring everything to one side. That's it's going to be 1 when I subtract 3 on both sides. Subtract 6x, you get 3x. So x equals 1/3. Okay. Hope this is starting to make sense now. Let's look at these two examples. Now we got some fractions. Well, how can we account for a fraction? Well, if you have something on bottom, you want to bring it up, you can just make the exponent negative. So first, what is the common base between 9 and 27? Well, 3 squared is 9 and 3 cubed is 27. So I can, here, I won't skip a step this time. I'll show you step by step on the first go around. And then on the next time around, you'll see that you can just do this step in your head. So you're going to have 3 to the negative 2 times x plus 2. And actually, if you want, we can raise it first. Let's not skip any steps at all. So 3 to the negative 2. Sorry. Well, I am just pressing that button crazy, aren't I? Let's change the grip. multiply the powers. Distribute through the exponent. Then bring the x's to one side. And the numerical values to the other side. So all I did was add the 2x over, subtract, or add the 9, sorry. And then we get x equals. Okay. So only new thing here is that negative exponent. If you want to go directly from this to this step here, then please, if you feel comfortable, do so. That secondary step is not necessary. Let's look at this one. For instance, if we have 2 to the negative 1 raised to that, I can automatically go to this step. Because how did I do that? Because that's 2 to the negative 1 raised to the 3x squared. And then 1 power raised to another power, you multiply the powers. And then we have 2 to the third, negative third, times 3x plus 2. And that was because that was 2 to the negative 3 raised to that 3x plus 2. So you multiply. So this step right here, you can do in your head if you want. That's fine. Like I said, and we'll always say, the more you do this, the more second nature it becomes, and you will end up doing more stuff in your head. So set the exponents equal to each other. At this point we have an equation, so what we need to do, ooh, I think I messed up, didn't I? That needed to be just an x plus 2. I apologize, everybody. Creative license here. Just for the polynomial's sake. You could have done it the way it was. It just would have been a quadratic formula problem, and I didn't want to do that to you guys. So if you bring all of it to one side, you're going to get a 0 equals 3x squared minus 3x minus 6. You can factor out a 3 from there. Then you'll be left with x squared minus x minus 2. And then this factors into x minus 2, x plus 1. So 3 will never equal 0, but x minus 2 will equal 0. So x equals 2, if you add 2 to both sides. And x plus 1 equals 0, so x equals negative 1. So those would be your 2 answers, okay? So again, all I did was I erased, there was a 3 here, and I erased it just to make the polynomial easier to deal with. So hopefully that didn't make anybody's head explode or anything. But practice, 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 that's the main thing. I hope this has clarified the same base examples. Thank you and have a nice day.